today I'm going to talk about some advanced Spotfire techniques, but a sort of obligatory thing I have to do is going to give you a bit of an introduction to the company and what we do. So we are an AI drug discovery company. Our mantra really is better drugs faster. And what we're really trying to do is we're trying to encode and automate every stage of the drug design and development pipelines. And we've got a validated platform and we've got a pipeline that's rapidly scaling. We've got lots of collaborations with pharma companies, but we have our own internal pipeline as well. But this slide really kind of shows you how Exscientia works and how we use our AI in drug design. And so on the left-hand side, you start with our project objectives, what we try to do with the drug discovery project. We look at available data, and often that'll be public data, so it could be data that's in likes of Kimball. And we maybe got some proprietary starting points. And then we do this, the design make test, and we call it flywheel of data here. And so the first thing we do is we take all the data that's available, the public data, and we build machine learning models on that data. And then based on those machine learning models, we then use our generative design algorithms to design new compounds, and there'll be like a large population of compounds that will come out of that process. And then we use a technique called active learning, which is really what we're trying to do at this point is we're trying to kind of improve our models. Okay, so we use that to go from the thousands of compounds that we've designed from our generative algorithm to try and get that down to the 20 to 30 compounds that we want to actually make in a design cycle. So once we use this active learning technique to kind of smartly select the best compounds, the most interesting compounds, or the compounds that give us the most information, we then synthesize the compounds, and then this is kind of like a kind of traditional pharma there. So you synthesize the compounds. Normally this is a CRO, but we've got our own labs and are developing automated chemical synthesis as well. And then we put that, the compounds get tested in the biological assays, and then all that data gets reintegrated into our models, and we re-update all our models. Then, we continue around the cycle. So the idea is then that the next generative design cycle will be, we'll produce better designs because the models will have more information. And I really like this slide because we could talk about where we use Spotfire within Exscientia. So we use it in a lot of places here. So with number one, models. So we're tracking all our machine learning model performance. We're using Spotfire to do that. So we've got analytics on how our models are performing over time. We've got analytics on the different types of model we're doing and which models are performing better. We've got analytics and all of that, and that's all done in Spotfire. In terms of chemical synthesis, we've got dashboards now that look at chemical synthesis. Compounds we set to the CRO, we can kind of keep a track of how long is it taking the CRO to make that compound. And if the CRO, if it's taking too long, we can look and maybe some other similar compounds have been synthesized, and the models are now trending because the models are constantly being updated. Then maybe this compound actually is not looking such a nice compound anymore. So maybe we could just actually cancel the compound before we even synthesize it. Biological testing, we're using Spotfire there. So we have our own kind of internal version, the internal tool, which is equivalent of Vitro. And so we've got dashboards that allow you scientists to look at the dose response curves and look at the results. But also what we're doing here as well is we've got a keen focus on how long does it take us to design compounds, how long does it take us to synthesize, how long does it take us to test, and we're constantly trying to drive that number down. There's really high profile within the company, and so these So we've got analytics on all of that, our cycle time, and that's all done in Spotfire as well. And that's a very high profile within the company. That's part of the goal is to try and reduce our cycle time. And then kind of the sort of what we use Spotfire a lot for is this update and integrate project data. So this is Spotfire's where our medicinal chemists, our biologists are going to look at the results. And so the chemical structures, the SAR kind of analysis, the kind of traditional type of use cases within the farm industry. Right, so today I'm going to sort of talk about some of the challenges we've faced, and really going to talk about how we've been able to use use some of these advanced features to actually solve these problems. So I'm really coming at it from a kind of a problem, and then how you can use these techniques to solve the problem rather than just sort of concentrate on the problem. So the things that I want to cover today are Python data functions, and then kind of confusingly IronPython, but I'll explain the differences between them. And then some other things that maybe people are not so aware of, so configuration blocks and automation services. And then I'll kind of give examples of all of these things, but in the end, what I'll do is I'll have a kind of bigger example which uses multiple of these techniques together to affect a kind of bigger goal. So we're going to start with Python data functions, and we saw a bit of that yesterday. So what are the kind of challenges that we have? So we have Exscientia's a lot of tech people, a lot of very bright computer scientists and engineers, and we use the cloud a lot. We use AWS, and we have things like this. So a computational chemist, they've run some generative algorithm, and they've output that to an SD file in AWS, and then they say to the medicinal chemist, do you want to have a look at that? And it's I don't know how to access AWS. I don't understand how to access a file in S3. Or another example, we've a lot of data scientists, and they're building lots of great models. So they built a great ADA model, and they say, there you go, we go and have a look at that. And they say, I don't know how to access Python. I don't know how to access any of that. And another example is where our AI engineers have built a new package, a new Python bank for clustering. And, so their documentation is a Jupyter notebook. This is how you could use this to do chemical clustering. And again, some medicinal chemists are not, they don't have the experience. They're not, as I say, not everyone is a Pythonista, right? So that's the kind of problems we've got. So how can Python data functions help with this? Well, the thing with Python data functions is that it adds real Python, and kind of that's important, the real Python part, to a familiar and easy to use environment, i.e. Spotfire. And when I say real Python, what I mean is you've got access to all of the Python packages, and you can kind of install them in the Spotfire servers. There are a bunch of chemistry specific Python packages like our ReadKit, for example. So you can use them within Spotfire. Exscientia, we built quite a lot of our own packages, so we can leverage that. And we can use our internal packages within Spotfire. And the thing here is users, they don't need to understand the code, the complexity for them, how all that works is all hidden from them. And so we can significantly extend Spotfire functionality. And in a lot of cases, the problem that we've got here, we've got Python code that can solve that problem. So we're not writing huge Python data functions. These things already exist. It's just leveraging stuff we already have. And of course, the lovely thing about Spotfire is you can do these complex calculations, but you can then straight in an environment will allow you to really explore those results and visualize them very easily. Right, so how do they work, these Python data functions? So basically what you do is you've got data in Spotfire, and you can then send that to Python, do something in Python, and then return that data back. And when you're passing data in, you can either pass a table of data, so a Spotfire data table, or and when that appears in Python, it becomes a pandas data frame. And then when you've done some processing on that, you want to return that data back, then you just return the Python data frame, added as data frame, and that becomes a data table in Spotfire. It's very simple. And so a column becomes a Panda series, and you can put in scalar values or string values as well. And when you're setting up your Python data box, you can choose whether you want to put all of the data in a table or all of the data in a column. But you can also say only set data that's been filtered or marked. So that's really powerful. So that allows you to kind of specifically, mark some specific compounds, for example, and say perform some function on just that data. And the nice thing as well is you can kind of embed it into a dashboard. So you can have an existing dashboard, you can add some Python data function there. So we have one to calculate the Gini coefficient of when we're looking at kinase screening, for example. And that all works. It works through marking, and it's kind of transparent to the user. The user has no idea they're using Python. That just all happens kind of behind the scenes. But you can also have them standalone. So this is what we saw yesterday. So in the FX flyout, this in Spotfire. So what that means is you're in a dashboard that someone's created for you already. You can just access one of these Python data functions, or it could be a file. It could be Spotfire. You can load in CSV files, XML files, connect to a database. All of these things. That's not a problem. You can just make them available, very easy to use from the end user, and suddenly they've got all this excellent functionality that they can access. So the first case study is this here, it's file on the AWS S3. So we wrote a very simple data function to do that. And this shows you what it looks like. So it's a standalone one. So you click on the FX, you have this bunch of Python data functions there. Read S3zip SDF file. All you have to do is tell it what the path is, the S3 URL. And kind of what's happening behind the scenes here. So in Spotfire, you specify the S3 URL, and then the Python data function takes that and reads that data in and has that data as a Python data frame. And then all we do is we return that as a Python data frame. And now that just reads the data in. So you now got access to the S3 but you couldn't before. And it's just like opening a file. It's very simple to do. So that's the first kind of case study. The second one is to do some global array predictions, and we actually have a kind of scalable model platform that does all our machine learning, so what we've got here is like a user can load in like an SD file of compounds, or they can load in from an existing dashboard, and then they can add in the global array predictions. And again, it's very simple for the user to do. It's in this FX menu, so they just say global array, and all they have to do is tell the Python data function which is the column that has the structures, which column has your chemical structures in it. And what we do here is actually the Python data function is kind of a bit smart. It knows, it doesn't matter whether it's the smiles or it's mol files. The Python data function, we've coded it up such that it will say, it will convert it and then send that off to a model platform. That happens all offline in another system, and then we get a Python data frame coming back, a pandas data frame coming back, which we return, and the users get a nice table with all the predictions. And say this is because it's standalone. They can do for it whatever they want. So if it's a file or it's in a database, they can add this functionality for. So, if you want to get down, they do some of the Python data functions. I could give you some kind of lessons learned there. What I would say is some of the challenges. Python package management is a bit of a nightmare. So if you've got packages that are kind of dependent on another package and they require different versions, that can be a bit of a hassle to deal with. There are some kind of limited UI options, so for the sort of standalone functions, so in that's a bit more limited. But there's a lot of opportunities here. So what I would say is it makes this complicated functionality available to users without any Python experience. So you're really democratizing access to this complex functionality. Yeah, as I said before, we could leverage existing code. So a lot of the time, our designers or our data scientists have already written code, to do this functionality. So we're just kind of leveraging what they've done already. So there's a huge advantage there. And what's nice as well is this. So like the chemical clustering, for example, there's so many different tools that can do chemical clustering. But the nice thing is here, we're not just adding another chemical clustering tool, we're adding the kind of company standard clustering algorithms. So whether a designer does this in a Jupyter notebook or they do it in Spotfire, they get the same results because it's the same code that's running. One thing we've done to kind of reduce this packaging challenge is we've actually got a whole kind of scalable web services platform, which it's all in containers, and so there's like a function there to do, say, clustering. So instead of having a clustering package and having to install it into the Spotfire, all we do is to call out to this scalable web services platform, and it will scale up to, how the size of the job that's that it is. And so then all of that kind of Python package management kind of disappears because that's all in containers, and there's like, container for one function and a container for the other function, so the packages don't interfere with each other. So that's a kind of top. So that was Python data functions. So now I'm going to talk about Python, which is obviously a bit confusing because it's Python again. So here's some of the things that we're doing with Python. So here's some of the challenges. So got a nice scatter plot here. Everybody's seen these kind of scatter plots, and users, they love this, that you can get a chemical structure on the scatter plot when you mark. But, depending on the size of the screen, the resolution, the size of those chemical structures, the users want to change that. And they can do it, but they've got to go through and click multiple menus to get there. And if you've got a dashboard with multiple scatter plots like this, you would have to do it in every one. So that's the challenge there. Again, we saw this earlier. Correlation plots. Users love these correlation plots. They love. One of the things they like is these kind of fold lines here. So so you've got like the kind of y equals x line, but then you've got 3-fold and 10-fold, and they like to be able to see the different. Whereas we've got cellular assay, we've got binding assay. How do they correlate? So they kind of like these fold lines, but sometimes they don't like the fold lines, and they like to kind of just remove the fold lines. And again, you can do that. There is a menus that you can go through, and you can kind of go through and untoggle all of these settings. But the users will like a nice way of doing this. So this is where Python comes in. And, I like to call these things kind of convenience functions. Okay? So basically, they just take something that exists already within Spotfire, just kind of makes this stuff a little bit easier to use. So what we do here is we've got a scatter plot, and I've added a text area to the left-hand side, and we've got a slider on that. And that slider is linked to a document property. So that's if they add it across. So to really adjust that slider, adjust that document property. But the feature here is that whenever that number changes, a script is run. And so there's a very simple little script here, only a few lines of code here. And what that does is that it just loops through all of the tabs on your dashboard and all of the visuals. And if it's a scatter plot, it just changes the size of that structure label to be the size of the slider. Very quickly, you've got a slider. You just adjust that slider, and immediately on screen, the size of the structures increases or decreases. Very simple piece of code, very simple to do. Users love it. It's just a kind of convenience sign of Borland, but that's been really popular. So again, fold line. That works in a slightly different way. So instead of a slider, we've got a button. So whenever you press a button, it just executes an IronPython script. Again, very simple piece of IronPython. What it does is it just If the fold lines are enabled, disable them. If they're disabled, enable them. Really simple. So just click the button, the fold lines disappear. Click the button again, the fold lines appear. It's simple stuff, but yeah, adds a big impact for the users. So, yeah, it's a bit confusing though, this IronPython and the Python data functions. So kind of what's the difference? Well, IronPython is Python for .NET. So that's why I said this real Python when I was talking about the Python data functions. So the thing there is you don't have access to all the Python and the packages. So there's no scikit-learn or pandas, for example. But what you can think of IronPython is basically everything that you can kind of point and click in Spotfire. There is an extensive API behind it, and you can control all of that via IronPython. And so yeah, so that's really powerful. It's always embedded in a dashboard, so there's not any that way, the then kind of easy way of kind of adding this to a dashboard. You would have you add it to the dashboard, you save it, and then it's kind of there. And I showed you could trigger the code. You trigger it by pushing a button. So in the fold example, and you can trigger it by changing a document property. There is a way as well of getting these IronPython scripts to trigger when a dashboard starts up. And there's a typical article on that. Tell you how to do that. There's a little bit to do to get that to work, but that's a really powerful technique. And I'll come on to the kind of bigger use case and we'll show you how we use that. So, what to consider about IronPython? So, most functionality has an API, but I've found a couple of things that didn't. The API documentation is very comprehensive, it's huge, but it's complicated, and really if you're trying to work out what to do from the API documentation, you're going to struggle really. But I have to say, typical community has a huge number of examples, and I recommend looking on there. And I always just Spotfire, IronPython, how do I change the colors on a graph, and there'll be some code snippet there. So there is a little this kind of an essential copy and paste thing from Adam use Stack Overflow where we use the typical community because there's so many great code samples there. What I would say is you're gonna really struggle pretty quickly. You need to use an IDE to write these IronPython scripts because it's just the editing them in Spotfire is a challenge. So that's IronPython configuration blocks. So here's some things. So users, we have a notification system. Whenever there's any data, there's a notification goes out, and users would like to just click a link and just view that latest data. Yeah, they're always interested in what's the new data that's come, and so they would like to do that. We have a dashboard that's from public data, and they loads targets in, and we've got bookmarks set up, so they use you want to be able to kind of have a link directly to that bookmark. And so these are the kind of things that configuration blocks can help us with. And what they do is you can pass filters into a dashboard when a dashboard opens, and you do things like set which page you want the dashboard to open at, apply a bookmark, set filters, set marking, or you can also set some document properties. And you can use these configuration blocks, either URL, or you can use automation services, which I'll cover. So latest data, this is something we did like in a couple of hours. We had the notifications going out, and spoke to the engineer who built the notification, said, could we just add this configuration block to put the latest, to filter the data just to show the latest data. Very simple. We set the configuration block, we set which page we wanted to open, and then we said just filter it for the latest data. A really simple thing to do, but within 2 hours that was rolled out into production, and the users were over the moon with it because they have a link they just click on in the notification system. So configuration blocks, conclusion. Well, it allows you to rapidly create all these different filtering and views of the data with no extra code. You don't need IronPython code to do this. It can be dynamic. So this is what we do. We paste in the date. The only thing I would say is you need to, for the URLs, you need to encode them. So if you've got spaces or quotes or things, you need to encode that. Automation services. So things like this. So we want to back up our dashboards. We want to have a timestamp version so we can go back in time. Or this one's kind of interesting. Our dashboard does some. So we have some dashboards that just do data transformations. We use the data canvas to do all that, and we just want to export that data, but we want to do that on a schedule. And automation services could do that. So if you haven't seen automation services, this is what it looks like. Again, simple tool. And it's just like a set, it's like a kind of script of simple things that you could do. And here's on the right hand side, these are the things you could do: open a dashboard, save a dashboard, replace a data, and export data, stuff like that. And you just kind of chain these things together. So you have the script. So open a dashboard, replace, save a dashboard. Very simple. And you can use configuration blocks as well. The nice thing as well, these files are XML, so you can kind of edit them manually, or you can programmatically create them. You can schedule these automation services jobs to run, and you can also call them via an API, which is super useful. So here's like one for doing a backup. So you can put in dynamic dates as well. So it's a very simple one. Opens a dashboard, saves a dashboard, but it puts today's date in. So wherever that runs, we just get a new dashboard created with a date in it. So talk very briefly about how we could kind of bring all this stuff together. So we use this multi-parameter optimization, and we want our dashboards to basically customize themselves. So here we've got ACID A, ACID B, ACID C, but we could add ACID D, or we could remove ACID C, and we want our dashboard to completely update based on this. And we set these ACIDs in a different tool. So how do we get all that to work? And you see it's in lots of different places. So we've got scatter plots here, we've got a table, we've got an MPO plot, we've got a radar plot. All of these things need to update. So how do you do that kind of automatically with the user not having to do anything? So we do that. First thing is we use automation services, and we trigger that from our other tool where we select all this stuff. And we call automation services via REST API. We use a configuration block to set a document property, and then all of that customization of the charts is all done via Iron Python. And so this is like this kind of dummy script here, but what we do is whenever the dashboard starts, it checks this document property, update the MPO. If that's true, then it will run through and it'll design Python to customize all of those things: create charts, remove charts, add columns to tables, remove columns to tables. All that stuff is done via the Iron Python, and it saves the dashboard. So the next time the user goes in, they just see the extra charts there, or the charts have been removed, and that all happens all completely hands-free, automatically. And so conclusions. Python data functions allow you to add a lot of complex within ML to any dashboard. You can leverage existing Python packages. Iron Python, you can use to improve the usability of existing dashboards, and you can have complex customizations you can automate. You can use configuration blocks that like bookmarks or filters, that kind of thing, and you could use it to tell Iron Python to do things. And automation services, that's a useful tool for allowing you to kind of update dashboards through Iron Python. So, any questions?